All right, everyone, here's your first lesson online. Happy Monday. Please take out your homework or your definition sheet that I passed out, or the one that you maybe have printed out, or you can put this in your toolkit as well. Any of those work fine for me. If you need a second, go ahead and pause the video so that you can go grab that and follow along. First, I want to start and talk about this exponential growth and decay that we had introduced the week before we went on this extended break. And we said that the amount equaled some starting amount, that I'm going to multiply that by 1, either plus a growth rate or subtract my decay rate to some time. And here was our example on that. So how would I set up an equation to figure out how much money I had after 6 years? If I started with 1,000, then I want to keep 100% of that plus add the 5% interest the bank promised me. I'm going to have that all to the 6th power. That will tell me that I have a total in my bank account after 6 years of $1,340.10. So we're going to build on that equation right now because we're going to start talking about compound interest. This equation can be used with any kind of exponential growth or decay, whether it's animals reproducing or you're talking about money. And we're going to be really specific today where we're pretty much talking about money or investments. So we want to talk about first compound interest. And this is our generic compound interest, so we're not going to add anything to it. And it's really similar to what we had up here, except for we're going to have one new variable we talk about. Instead of putting little a, we have big P. So 1 plus little r all to the t power. Instead of a being our start amount, we call this the principal. That's the amount of money that either you're investing, the amount of money that is the start of your loan, the amount of money that you put in the bank. So it's still the start amount. And our example is going to be this. Here's my amount. If I write this equation, let me put a piece of paper under this because it's kind of writing rough. Sorry about that. If I write this equation, this says I have $100 invested at 6% interest for any amount of time. All right? Does that make sense? So it's really similar to what we had before here, except for this T, it can be months, it could be years, it's whatever standard amount of time that the problem has given you. And so we need to be more specific if we're talking about years and parts of years. And so for that reason, we're going to have another compound interest equation. So this one is simple compound interest. This is going to be compound interest where T is in years. So the difference between the one above is T can be any amount of time. It could be years, but this one is definitely only years. And here's this equation. So we have our amount equals our principal. That's still the amount of money we started with. We're going to keep 100% of it. That's what that 1 stands for. Plus any interest our interest rate, that's R, divided by N, all to the NT. So we've added some new things to this equation. And the main new thing is this N here and here. And N, that's the amount of times compounded per year. Oops. Sorry about that, bad spelling. And we're going to look at what an example of that would look like. So I'm going to write an equation and then I'm going to give you what it means. So it's really similar to our one before. When we're trying to find an amount of money, I start with $100. And then I have 1 plus 0.06, that's just 6% in decimals, divided by 12, all to the 12t. And what this is $100 invested at 6% interest, compounded monthly. So what that means is instead of the bank adding up my 6% interest at the end of the year, they're going to add it up, a little bit of it up every month. So at the end of every month, they're going to start with this value and they're going to add this little bit of amount every month, but then you can see that it's going to be to a higher amount for an exponent over here. And we're going to look at this more closely with your assignment today. All right. So if you have any questions, again, make sure you're notifying me of your questions. Our assignment today is only going to be page 1 of that compounding interest investigation that I gave to you on Wednesday before we went on this extended break. If you don't have it, it will be attached to this Google assignment. So go ahead, you can just go ahead and print it off there or just copy it from your computer to that if you don't have any way to print it. So I want you guys to do number 1 on your own. I'm going to start you out on this second part here. Just to let you know what I expect to see for this worksheet, I will be posting your answer key tomorrow. So we're talking about compounding annually. So that means the end of every year, the bank will compound the interest on this. And they're saying that we start with $1. So that's basically what this investment is built on. So in this field, we're going to fill in N, the number of times I'm compounding per year. Well, I'm only compounding once. That's what we said. So it's 1 plus 1 all over 1, all to the 1th power. So how much are you going to end up at the end of that? You're going to have 1 plus, this is another 1, so 2 to the 1st power, so just $2, right? Does that make sense? So now semi-annually, that means I compound it twice a year, so every 6 months. So let's see how that equation changes. 1 plus 1 over 2, all to the 2nd power. If I add this up, it is 1.5 or 1.5. If I square that in my calculator, I get 2.25. All right? All right, so I'm going to leave this here as my lesson for today because it's plenty long of a video to watch. Again, just to restate, and it will be in the Google assignment as well, you are just completing page 1 of the packet that I passed out on Wednesday that will also be attached to this. All right. Talk to you later.